So what we're going to be doing in this video is we're going to be solving linear systems by substitution now. Before, we spent a lot of time and we were graphing them. Now, we're going to be learning a new method, which is substitution. So a linear system, when solving by substitution or by graphing, is the same thing. It's two or more linear equations that have the same variables. And when we're solving it, we're still trying to find that ordered pair, the ordered pair that works with all the equations. When we graphed it, we had 3 steps to solve it. When we solve by substitution, we have another new 3-step system to solve it. And the first step in solving it is we are going to isolate a variable. We need to get a variable by itself. Isolate the variable, get it by itself. And it can be x or y. You can get the x by itself, or you can get the y by itself. It doesn't matter which one you want to solve for. So the next step after that is we're then going to start substituting. We're going to substitute we're not just going to substitute. We're going to substitute an entire equation. We're going to substitute an entire equation to find that ordered pair. Once we substitute the entire equation, we also need to simplify. With any step, whenever you're working with an equation, you do need to simplify the equation. So we're going to substitute the entire equation and simplify. And after we've done that, simplified, we should have an answer for one of our variables. We're going to substitute again. But this time, we're going to substitute just the variable. We're going to substitute just the variable. So first, we isolate a variable, get it by itself, get the x or y by itself. Then we're going to substitute an entire equation and simplify. Then we're going to substitute just the variable. And again, we have to simplify. So these 3 steps sound confusing. Not too bad once you see them in use. But it's important to have these down, know these 3 steps. So I would write this down somewhere, so when we go on to the next part, you know what I'm talking about when I say we're on step 1, or step 3, or step 2. Write it down somewhere so you have it during class also. I'm going to show you how to use these 3 steps now. So we isolate a variable, substitute, and substitute again. So we want to solve using substitution. We want to solve this linear function for x and y. Get that ordered pair. So our first step was to isolate a variable. Sometimes the first step will be done. Do we have, on the first or second equation, do we have a variable by itself? Do we have y equals something or x equals something? Look at it, and you'll see we have y equals. This variable is already done, so step 1 is done. Since step 1's done, it's given to us done. We then can move on to step 2. Step 2 was substitute an entire equation. So we need to use both of these equations. We see that y equals 3x plus 2. So 3x plus 2 is the exact same thing as y. And we have this second equation. We know y equals 3x plus 2. We can plug that in for y. So I get x plus 2y, so 2 times y. But instead of y, I'm going to substitute in what y is equal to. So I get 2 times 3x plus 2 equals 11. We've now substituted in the entire equation. But if we look back to our steps, we also need to simplify. So now I'm going to simplify this equation and get x by itself. So I get x plus, to get rid of these parentheses, what I'm going to need to do is the distributive property. So I'll take 2 times 3x, 6x, plus 2 times 2 is 4, equals 11. I'm going to continue simplifying. I don't have a variable by itself yet. So x plus 6x, 7x, plus 4 equals 11. Now it should be pretty simple at this point. Subtract 4. We get 7x equals 7. Divide by 7. X then equals 7 divided by 7 is 1. I have now got x by itself. I have substituted an entire equation and simplified. So I'm now done with step 2. I got that x equals 1. Now we can use this and go on to step 3, which is substitute just for the variable. Our variable is x, and it equals 1. What we need to do now is simplify that into one of these two equations. It doesn't matter which one you use. No matter what, we're going to get the same y. I'm going to use the first one. I could, because y is already by itself. So y equals 3 times x plus 2. So y equals 3 times x. I know x equals 1. So 3 times 1 plus 2. So y equals 3 plus 2, or y equals 5. You could have plugged that into the other equation and got the same thing. So I'm going to do that. X, which is 1, plus 2y equals 11. Subtract 1, subtract 1. 2y equals 10. Divide by 2. Y then equals 5. Regardless which equation you use, you get the same y. Our y, no matter what, is going to be 5 if x equals 1. So if we solve using this, we need to write an ordered pair. Ordered pair is xy. The x that I got for my solution was 1. The y I got for this solution is 5. I actually got it twice. You only need to do this step once. I only did it twice to show you that it works for both equations. It doesn't matter which one you choose. But we got 5. So 1, 5. And that is our solution to this problem. 1, 5. We've got the ordered pair and it works for both equations. Don't believe me? Plug them in. We get the same answer, or they're both still true. 1, 5. Couple steps. Instead of graphing, though, we're going to be doing all these algebraic steps. So if you don't like graphing, this is probably a better method for you.